translating from, like I said, math to words and words to math. So our first box here says translating verbal expressions to algebraic expressions. That means going from, what did I say? So we're going to go to words to numbers here, because the order here says verbal to algebraic. If we go from verbal to algebraic, that means it's words to numbers. Okay? So right now, you're filling in that box that I just uncovered. So your first box should be words to numbers. Are you filling it in? So I just uncovered your first box is this words to numbers. You already read it? No. All right. So to translate verbal expressions to algebraic expressions, you rewrite using numbers, it says variations, that should say variables. So let's fix that word. Variables. And operation symbols. What are the operations? There's 4 of them. Who can tell me what the operations are? What are the operations I'm talking about? Yes, addition, subtraction, multiplication, and division. All right. So, if we're talking about this, this is the addition symbol. So another word for addition is plus. So you're writing that in the box below the addition symbol. Let's see. Okay. Another word that means plus is the sum of. So it's not a word, but it's an expression. So you might see the expression, the sum of. If I say the sum of 2 and 5, tells me, if I'm translating that, that's 2 plus 5, right? So we're writing the sum of in the next box. Increased by is another really common way to say you're adding. Increased by. And not the only other way to say it, but more than. If I say 3 more than 5, that would be 5 plus 3. Okay. Thank you. So look at your sheet that I gave you that I told you you didn't have to do anything for. So look at addition. Is there something else there that we did not talk about? Added to, the total of. So that's just a couple more things. There's a lot more ways that you could say, that you could indicate addition with words, okay? And look at the examples there. Let's look at the examples for addition. I'm going to pull up my copy of that. So, oh my goodness, bless you. All right, so this is that. You don't have to do anything with this. This is just information. But so we're talking about addition, and you can see here a number plus 3. We would translate that to x plus 3. So one thing I don't think I have in your notes, so we'll add at the bottom. If you see the expression a number, that means you have to use a variable. So the expression a number indicates that you are going to be using a variable. If it says a number y, then you have to use the variable y. So let's go ahead before I forget that and put it in our notes somewhere. So let's put it kind of out here and with an asterisk. The expression a number means to use a variable. All right. So in that, on that sheet, a number plus 3 is x plus 3. 10 more than a number is 10 plus x plus 10. The sum of a number and 5 means, where it says a number here, we put in x. Where the and is where we put our plus and then 5. Does that make sense? All right. So let's talk about some of these subtraction words. Anybody think of a word? I just said subtraction, so you can imagine that's one of them, right? Do you think of another one, Denisha? Minus. Let's see if there's minus. That's the first one. Oh, takeaway. I think takeaway is there. Takeaway is not there, but definitely takeaway is one, right? We take away something, we reduce it, we get rid of it, or anything like that really could be subtraction. So let's go ahead, the difference of. So all 4 operations have a word that represents what you get when you add, you get a sum. What you get when you subtract is a difference. What you get when you multiply is a product. What you get when you divide is a quotient. Well, that should all sound familiar. So let's go ahead and fill in the difference of, decreased by, and less than. Alright, so this, we don't normally use an X in multiplication, so let's put a dot here. So we're either going to use a dot or parentheses. So instead of an X, let's put a dot. We already talked about time, so I'm going to kind of move through that one a little quicker. Talked about that at the beginning of class. So times the product of, so we just talked about that. That's what you get when you multiply things, you get a product. So if you see product, now you know that you had to multiply to get that. So the word of means to multiply. You guys might not have known that, but the word of means to multiply, especially with regard to fractions. If I say 1/2 of 100, what is 1/2 of 100? 50. And if you see what math that you have to do to get that, 1/2, you don't have to write this, but I just want to show you. 1/2 of 100, so that would be 100 over 2, then we divide by 2 and we get 50, right? So 1/2 of a number, we've multiplied by that fraction, right? So of means to multiply, and that's actually a super important one. So let's put a star by it. It's kind of a vague one, but it's really important, especially with fractions. So go ahead and put a star by that one. It's one you might not really think of either. And, oops. Oh, there's not another one there. All right, let's look at the, let's look at the sheet I gave you. So we didn't look at the ones that say subtraction. So minus, less than, the difference of, and less. So these two are not the same. Do you guys see less than and less? They do both mean subtraction, but they're a little different. So we're going to talk about that in a second. Decreased by, subtracted from, even the takeaway, that's a good one. Let's look at multiplication. Times, the product of twice and double. What do the words twice and double mean? Multiply by 2, not just 2, right? It means to multiply by 2. And the word of there. So let's look at an example here. 8 times a number. So that's going to get written just as 8x. If we don't see the operation between 8 and the x, we know it's times. Alright, so I can fill in our table with these few. So this symbol is the division symbol. So divide, it makes sense, but that's one of the words that would indicate division. If we have a verbal expression and we need to translate. The quotient of, so all of these have those special words that depend on the operation that we're talking about. So the quotient is what you get when you divide things. Divided by among, so if you split things among 10 people, that means you divide them among 10 people. So if I have 50 chicken wings and I split them among 5 people, 50 divided by 5, everybody gets 10 chicken wings, right? Once you're finished writing, go ahead and look at the other paper I gave you and look at divide. See if you see anything that looks wonky there. The ratio of, yeah. Alright, so the quotient we talked about, but divided by, but the ratio of. So remember, a ratio is a fraction, and a fraction is a division problem. So just like over here when I did 100 divided by 100 over 2, that's a ratio. 100 divided by 2 is also division. That makes sense for you? That makes sense, Caleb? That makes sense, Shamari? Mm-hmm. Makes sense, Davion? Okay. Alright, so here's the catch. So let's go down here, and let's just do one of these before we finish up there. So let's go down where it says write each as a verbal expression. Can anybody tell me how to write 25 increased by 6? Aiden?
25 plus 6.
25 plus 6. Is there any other way to translate that? Can I write any other expression there? There's only one way to go from words to math. Alright? Say it again. What'd you say? How about the product of 7 and 12? Jeremiah? Very good. Now, if I'm translating this, like I'm translating from another language, could I write 7 times, or 12 times 7 here? No, because if we're translating it, we want to do it in the correct order, right? I'm trying to learn German right now because I'm going on a big trip, and everything is out of order. And that's one of the hardest parts for me. The parts of their language aren't in the same parts of the sentences that English is, right? So the order does matter. When we're translating, the order matters. Now this one is tricky. We have not talked about this yet, but this word here is a tricky word. This expression says 11 less than 20. Janice is exactly right. So why did she put the 20 first? Because 20 is not first here, right? That's a tricky one. Anytime you see the words to, from, or than, you have to change that order. So this is actually 20 minus 11. If you think about it, it kind of makes sense, because 11 less than 20 means you started with 20, and now you're taking 11 away, right? But now let's do this one. Let's add an example in here. You guys ready? Let's add an example here. Let's do 11 less 2. What's the difference there?
11 minus 2.
It is 11 minus 2. Wasim said this one is 11 minus 2. This one, because of this word, things aren't in the same order when we translate them. It doesn't mean the same thing if we translated 11 minus 20. 11 minus 20 is negative 9, right? 20 minus 11 is positive 9. So the order matters, and that is one of the tricky things here. That one will catch you. I'm just going to tell you right now, that word is on the test. So you have to know what that means. Okay? So let's go back up here. To, from, and then tells you to switch the order. To, from, and then tells you to switch the order right here. So how many ways can I translate 10 times x to math? How many ways do we say? How many answers, how many different expressions can I write that means the same thing as that? Just one. There's only one right answer when you go from words to verbal.
This is right.
Thank you. All right. I don't. Okay. So there is. So now we're in this box right below here. There is only one way to translate verbal expressions to algebraic expressions. Only one way. If we have math and we're changing those to words, translating that to words, so if we have numbers and variables and we're translating that to words, then we have a lot of different ways we can say it. Right? So if I have, well, we'll talk about it in just a second. All right, let's look at our table of things that I got and look at some more examples. Oh, one of the ones we don't have in our notes, so we really need to put that on there. Vivian, why don't you, okay, look at me. Look at me. You're sitting here, you said, because you can't see. But if you're going to laugh and cut up, I'm going to sit you at my desk. You'll be able to see great there. Well, all I did, I just hear you laughing. Caleb, I don't know what you're doing, but you need to stop. All right. Powers. Let's go back here. Exponents. Exponents are also powers. So if you see powers or exponents, they mean the same thing. Let's see if I can see. Exponents are indicated with the words the power of, squared, or cubed. So adding this to exponents are indicated with the words to the power of, squared, or cubed. So if I have 3 cubed, that means 3 to the third power. If I have x squared, that means x to the second power. If I have y to the power of 4, or whatever number, y to the power of 4, y is my base, and 4 is my exponent. Y to the power of 10 is y with an exponent of 10. Y to the power of 100 is y with an exponent of 100. Does that make sense? Okay. Alright, so let's go to the bottom of our page and we need to talk about equal sign. Equal sign. Let's look at our table. So obviously that sign means equals, right? So we're going to write the word equals. We've got our cheat sheet. What's another thing that that indicates we're going to use the operation symbol equals. What's another thing? Jalen, can you tell me something else? Another word? Jalen? Yields or amounts to. And I heard somebody say is. Who said that? So that's the one you're going to see probably the most. Is and equals, but yields, amounts to. Is there anything else on that list that we haven't talked about on your cheat sheet? It's the same as. Stick your head up, Alex. Don't put your head back down, buddy. Okay? We're writing right here at the bottom of your paper now. You should be writing what I'm writing. Equals, yields, it should say amounts to, not just amount. I got the word to here. Amounts to. Is that all they have? All right. Can't think of any others right off the top of my head, but makes sense so far? Sorry? All right, we got more to do. All right, so now we're gonna flip over to the other side. So translating algebraic expressions from verbal expressions, from algebraic expressions to verbal expressions, let's scratch that word out, that's wrong, means going from numbers to words. So from algebraic expressions, so the algebraic expressions are the numbers and variables. Verbal is a word, so it's numbers to words. So that's what you're putting in that first blank. So, do you remember how many ways are there to translate algebraic expressions to verbal expressions? How many? There's one way to go from verbal to math. How many ways can we go from math to verbal? The Paul says 2. Let's look. Oh, it's kind of like it. That's x plus 2, right? Or 2 added to x, or x increased by 2, or 2 more than x, or can you think of any other ways? There's a bunch of ways. If I have the algebraic expression, there's a lot of right answers to give a verbal expression. A lot of ways to translate the math to words. But there's only one way to translate from words to math. All right? And that's important because when we have scientists talking about something, if they're using their words have to translate to the only one mathematical statement, right? There's a bunch of different ways to say it, but they all have to mean the same thing, and it's only one. So anytime you're translating from math to words, there's lots of right answers. But anytime you're going from words to math, there's only one right answer. Okay? So that's what we're going to put in that next box. I think it's many ways to translate. Many ways to go from math or numbers to words. So we're going to do these together. I just literally wrote that one. So here's my suggestion, my recommendation, my strategy for you to not mess up going from math to words. Keep it simple, all right? So there's lots of ways to say that. Probably the easiest one, though, is just, yes. Yep, there are many ways to translate algebraic expressions to verbal expressions. So this is an algebraic expression. Algebraic expression means math or numbers. Numbers and variables, right? So we could say x plus 2, 2 added to x, where that's the one I just gave you all those examples for, right? But all of those things I said all mean this, right? So if I say x plus 2 and Amari says x increased by 2, both Amari and I know what we're saying is that, right? There's only one way to go from what I said to math accurately. The same thing with him. Are you good, Sam? All right, so let's go ahead and keep it simple. So let's just write x plus 2, and I'm not going to make you spell out the numbers. Even though we're going from math to words, we are going to use the numerals for the numbers. All right, so who can help me with this one? This is a fraction or a ratio. Very good. T divided by 8. Don't blurt out for me. How can I, oh, not that, I can't use a symbol. We're doing words, not B. It needs to be, it could be T, so T divided by, my bad, we're going to words, divided by 8. It could also be a number T divided by 8. You're going to see that expression, a number, a lot. What do you think, Gloria? Perfect. We could say 9 multiplied by m, but keeping it simple is the best strategy for you. Can you drop that in the backpack? You trying to trip me with things? All right, Aiden, can you do the next one?
C minus 5.
Yep. C minus 5. Now we could say 5 less than C and use that tricky word, right? Well, I say we don't get cute, right? If we're going from math to words, let's pick the easiest, most straightforward one. Now if you see 5 less than C, you have to know how to translate it that way. Alright, so let's do something besides, we're still going to keep it simple, y plus 7, let's say something else. So Paul? Y more than 7. There. So y more than 7 would be 7 plus y to Paul, from that than word switches it, right? What'd you say, Kavion? Yes, y increased by how much, Kavion? Yep. Alright, this is a little bit tricky, because this is technically a division problem, right? But it's also a fraction. So 3/7 is the fraction, and h is the variable. How can we translate that to a verbal expression? Don't say it like I just said it, because most of these things you're going to need an operation for. So you need an operation. What's the operation happening here, Sam? What's the operation happening here? Add, subtract, multiply, or divide. Right here is divide, so it's a little bit confusing, right? Multiplication, right? Normally if you have a fraction and a variable, it's multiplication. So you could say 3/7 times h. It's also 3/7 of h. So that's a really common way you're going to see it. So we're going to actually write both of those. 3/7 times h, and we're going to say 3/7 of h, just to remind you of that word. If I were you, I'd write 3 times d here, but I'm going to change it up a little bit because we've already done some multiplication with coefficients. So let's say the product of 3 and d. If you see this expression, you have to know that it means that. What about the next one? How would we write the next one in words? Can you come out and write the next one in words, Josh? How can we write this one in words? Well, give it a whirl. What's the operation? addition, right? So we know we're adding. What are we adding? There you go. You just said it. N plus 1/4. That's it. That's all I get to do there. Okay, Josh? Alex, can you tell me how to translate this next one? Yep. B minus 10. Minus and that subtraction symbol are so interchangeable. I almost with the minus symbol, just my brain was translating it, keeping that minus because they're so interchangeable. Aiden?
You do like this with like
From here? So this could be 10 subtracted from B. You could say it that way. B subtracted 10 is another way. I don't like that way, but a lot of people say it that way. It could be B decreased by 10, right? But if you're given the algebraic expression and you have to put it into words, the best strategy is to just do the simplest ones. The harder ones are when they give you the words and you have to do the math because they're gonna give you some funky ones, right? How about this last one here? Shamari, can you tell me how to translate this one? Perfect. K divided by 2. You cannot. That's a great question, Wasim. Thank you for asking me that question. You can't because over is not an operation, right? And so I need to translate it in a way so I know what to do with those two expressions, right? If you say K over 2, I don't know what to do, right? So that is all of our notes. But I am happy to go through and look through your homework with you. Let's pick about 3 or 4, and I'll do 3 or 4 of your homework from your homework is the variable and variable expressions worksheet. I know I give you lots of paper today.
Oh, you did it? You did it?
I think we're going to do them all because there's no math to do with them, right? But I'm going to do some with you. There's 1.
You got my word down?
There's 2. You're going to watch the video. You're not going to take his notes because he's going to be using his notes.
I am.
Here's your 3rd one. And this one is just for information. You don't have to do anything with this one, sorry. But that one's just like our cheat sheet. Okay. Once you're through with your variable and variable expressions, Shamari, you're going to let him copy your notes. I prefer you watch the video, but alright, so let's pick some of these problems and I'll do them with you so you don't have to do them all on your own. Look through the variables and variable expressions worksheet. Is there one you want me to do with you? Is there one that looks confusing? Wasim? Number 7. The sum of Q and 8. So number 7. What'd you say, Jalen? It is. That's great. So number 7. I'm going to go to the page. Yay. Look at me. I'm so organized for a change. I got the worksheet right there. I forgot I had it. So the sum of Q and A, that's what we're going to add. The trick here is, Wasim, if you see this word, it's going to have 2 expressions. Where the and is, that's actually where the plus goes. Right? So this is going to be Q plus 8. All right? Anybody else? Look through and see if there's one you guys want to do together. Number 9. Twice Q. What does the word twice mean? Multiply by what? By 2, right? If I say, I want to get paid twice as much, and I'm getting paid $25 an hour right now, that means I want to get paid 25 times 2 per hour, right? Which will never happen. Oh, sorry, bud. I'm going to put your phone up, man. I shouldn't have to ask you again. We had this conversation Monday. Not yet, not right now, we're doing this right now. So twice P, so it's, I'm sorry, 2 times Q is just 2Q. Jacob?
Can you do number 4?
Number 4. Half of 14. So how do we write the expression half? Sorry? So the word half, isn't that a half? So it's just half of 14. So of is multiplication, remember? Half of 14. So 1/2 times 14. So Paul, are you following along with us, buddy? It doesn't look like you are. Oh, you like your pencil? Okay. Anybody else? Look through them. I don't want. I'm not tricking anybody. 8. 6 squared. So look at your notes. Can anybody help us do 6 squared? Aiden?
6 and 2 on top. Square.
Yes. So Aiden said a 6 and a 2 on top. We call that an exponent. Exponent of 2. 6 raised to the second power of 6 with an exponent of 2. That's what it looks like. Anybody else? The 1. The difference of, what operation does difference mean? Subtraction. So let's put a subtraction symbol here. So we're subtracting. So just like the sum, wherever that and is, that's where the subtraction goes. Unless you see the word 2 from or than, then it goes in the same order. So here that's just 10 minus 5. Number 4 is right there. Right there. Mm-hmm. Aiden?
Can you do number 12?
Read me the words, Aiden.
In cube.
In cube. So look at our notes. What do we put for cube? We talked about that one. What do we put for cube number? Say it again. Again with a 3 on the top. Remember, if you look at your notes, cube means an exponent of 3. So n cubed. All right, we can look at the back as well. We've been going from words to math or algebraic expressions. Now, if you look at the back, you're just going to do some algebraic expressions to words. So look through and see if you're comfortable with those. What? 23. All right, 23. So this is an operation, right? What is that operation? That fraction bar is an operation. What is it? So we could say, go ahead. Beautiful. Perfect. The quotient of 60 and 5. Now, there's other ways to do that, because when we go from math to words, we have a lot of ways to do it. So the quotient of 60 and 5. So if we want to keep it simple, it's just 60 divided by 5. That's another way to write it. So you could write it, or 60 divided by 5. Because we're doing some, and you're missing out. We're doing all of your homework with you, and you're not writing it down, so you're missing out. It means you got more work to do, right? Yes. Yes. You also have to do the review worksheet. So the review worksheet is what your test is going to look like. You have a test tomorrow, remember? Test tomorrow? Remember all of your makeup work, anything that you didn't turn in, or you turned in and it was incomplete, you want to get some credit for it. It's got to be turned in by 7:30 tomorrow. Taj? Sorry? Number 9, we can do that one. Twice q is 2 times q. So we're going from words to algebraic expressions. So from words to variables and numbers. Right? Anybody else see one you're not quite sure about? You can be working them right now. You don't have to sit and watch me. So go work through them. If you have a question on one, we can work it together. I'd like for you to work on this. I'd like for you to go ahead and finish this. And then you should still have about 25 minutes or 20 minutes to work on your review worksheet. And then you just have to finish it at home. Hurry up, I'm going to stand here and watch you. Hurry, 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 hurry. Urgency, let's show some. This first one right here is the one I want you to go to. Ew, oh, sorry. Then don't get it. Come on back in. I don't have a cup for that. Yeah, I would not do that either. That's good. You need a bottle for that one.
Trying to tell you.
You did. What do you think? Any questions on any of them? So once you're done, you can come up and I'll let you check them. Come on up. That's my desk. I'm gonna. That's the wrong one. You through with all of them too, Jeremiah? Well,